All right. Well, next up is myself. So I was asked to talk a little bit about our Keystone Y bridge rehab project that we finished up last year. And take care of some of the administrative stuff right away. The bridge is owned by the state of South Dakota. I was the project manager for this project. We had a consultant we hired, Stantec, that led the design of this project. They had a sub-consultant, Wood Research and Development, and then the prime contractor was Core Construction here out of South Dakota. You can kind of see what the bridge looks like. We're going to start off with just a little quick guessing game, just kind of put some perspective on how things have changed since the bridge was built. So in 1966, Summit Construction was the prime contractor. There were 2 bridges, just over 3 miles of grading, 1 million yards of dirt to move. And what would have been probably the low bid cost for that project back in 1966? Anybody want to guess? D? Yeah. No, it was actually C. It was over 2.6 million back in 1960, so kind of gives you some perspective on the cost back then. And the bridge subcontractor, George Moore, was tasked with building these 2 bridges. And anybody want to guess at what the cost of the 2 bridges were? $398,000 was all to build those 2 bridges 50-some years ago. And so when we bid this project back in 21, Jack Core was the low bidder. And anybody want to guess at what the cost was just to do some rehab preservation work on the bridge? Close. Yep. 4.5 million was the low bid. So if some of you guys want to come sit, you guys sure can. Just come on up. We're South Dakota. We're informal. All right. So these 2 bridges were originally designed in-house by our DOT staff. There was Casey Wilson and Clyde Junt, who both later became chief bridge engineers in our state. And it was pretty awesome to think that we just had a couple local bridge engineers that designed these. And after they inspected the bridge for us in our contract, they said a lot of the ideas that they incorporated in this timber design was years ahead of what normal timber construction was back then, and a lot of that led to why the bridge was in still pretty good shape. A lot of times you recognize that these bridges are like the gateway to the Black Hills, because as you leave Rapid City and you take Highway 16 to head to Mount Rushmore or any place else in the hills, you cross over, under, or go by these bridges. And if we can get the video to work. I have a video that kind of shows the construction.
A critical junction to most of the travel centers in the Black Hills is the Keystone Y. Directly linked to the nation's interstate system, serves travelers going...
How do we switch the screen to...
Oh, I see. There. Now I have to do it from here. Okay, there we go.
In many directions. In the 1950s, traffic had already reached bumper-to-bumper proportions. There was a definite need for increased lanes and for a smooth interchange of patterns. Design engineers in the South Dakota Highway Department felt the interchange structure should be in keeping with the aesthetic values indigenous to the region and began working on plans. Envisioned was a wood arch span that would be harmonious with the Black Hills forests in preference to the more conventional steel and concrete structures. Also, during the early planning stages, Highway Department bridge design engineers Wilson and Junt had traveled to Portland, Oregon to study the feasibility of the proposed laminated wood arches. It had already been an extraordinary accomplishment in planning. Now it was to become an equally challenging feat in engineering and construction. In the northwest coastal area, work was begun on the arches and the supporting wood beams. Freshly timbered Oregon fir trees were barked and sawed. Then they were taken to Oroville, California for high-pressure chemical treatment. Inside huge tanks, the lumber was exposed to a liquid petroleum process which permeated it with pentachlorophenol. This was a preservative treatment which would reduce future maintenance so that the bridges would require only occasional surface treatment after completion. Next, the 2 by 14-inch planks were taken to the storage area at Timber Structures Incorporated in Portland. After company engineers inspected the newly arrived lumber, it was sent on to the planing mill. Here, as the planks emerged from the planer, they were separated according to grade. Only the first quality planks were sent on to the scarping machine. In the scarping machine, the planks were cut with matching sawtooth ends and glued together. Independently, each of the spliced planks became as strong or stronger than a similar plank with no splice. Thus, they were formed into the 91-foot segments needed for the 2 laminated sections of each of the 3 arch ribs. Next, the long planks went through an automatic glue spreader in preparation for the actual lamination of one board to the other. As the boards were laid on the lamination form, they were fitted into screw presses, which were operated by pneumatic wrenches. One arch was pressed, another was formed on top of it. The lamination required 8 hours in the press under 120 to 140 degree temperature before an arch was fully cured. When the arches and struts came out of the lamination process, they were sent through a Paul Bunyan planer. According to structure specifications, templates were placed on the beams and marks were made for drill holes, which would later accommodate the steel fittings which joined the arches with each other and to the bridge footings. A neoprene coating was applied to the end of each arch as a moisture sealant before the steel fittings were attached. Finally, with the assembly of the braced columns and the wrapping of the beams, the laminated spans were ready for shipment to location at the Keystone Y. Steel piles formed the foundation for the actual bridge footings. Divergent angles of the different piles were designed to control all of the varied stresses which would come to play on the bridge. Concrete with reinforcing steel bars was placed around the piles to complete the footings. Altogether, the predominantly wood-span bridge utilized 650 cubic yards of concrete and 500,000 pounds of steel. The timing was right for the arrival of the prefabricated wood structures, and they were on their way. Across Oregon, Idaho, Washington, and Montana, the arches were wheeling along to South Dakota and the Hill City siding. Hill City, just 10 miles from the Y, was the closest freight station. Here, the arches were loaded onto trucks in the same manner in which they'd been carried by the rail car. There was a difference, however, in the flatness of the road bed, and an unfortunate accident occurred. On a slanting curve of the road, the first truck was overturned by the weight of the arches. The second truck was immediately reloaded so that the weight would exert less lateral leverage on the slanting curve. No one was injured, but the 3 arch sections which fell with the first truck were rejected by the highway engineers, and 3 completely new arches had to be constructed. This time, the arches arrived at the Rapid City station, which, although it was 18 miles from the site, now provided a wider and leveler access to the site. At last, the wood spans were ready for assembly. Metal fittings from the rejected spans had been undamaged and were refitted on the new spans. Giant steel hinges joined the arches to their footings and allowed the slight physical changes which normally occur in bridges this size. With the arches complete, the braced columns and beams needed to support the bridge deck could be mounted. The deck of the arch bridge was paved with two simultaneous operations, starting at the center and pouring toward opposite ends. With this method of pouring concrete, it was possible to maintain a balance of stresses on the bridge during construction. Vibrators were employed to remove possible air pockets in the concrete deck. The Bidwell finisher machine was used to smooth the surface. In October 1968, a dedication was in order. It had been 2 years since the structural work had been let to Summit Incorporated of Rapid City and then sublet to George Moore, the bridge contractor on the project. Speaking that day, South Dakota's Governor Nils Boe remarked that the Keystone Y is an engineering accomplishment of magnitude, but that its enduring value lies in the service it provides and the aesthetic contribution it makes to the Black Hills of South Dakota. The rope-cutting event was a proud gathering of highway officials, contractors, and regional dignitaries. This unique tri-level interchange was open to traffic at the end of the dedication. With highway surfaces finished, peak season traffic moved with remarkable fluency. The challenge of aesthetic design complementing the urgent travel demands of the Black Hills region had been met. And the Keystone Y was happily wedded to the arteries of the American West.
All right, well, I think that video kind of helps really set the stage for the importance of this bridge to South Dakota and our citizens. I mean, it's a pretty unique bridge. It's not the biggest bridge. It doesn't carry the most ADT, but it's very unique, really fits the setting there real well. And so there was a lot of pressure to ensure that whatever work we did to keep this bridge in service was that it kept its significance to the Black Hills, both historically and environmentally. And so we knew that the bridge decks needed some work. We had a lot of spalls, a lot of D-lambs. You could see rebar on the top, so we knew we had very low clear cover. We thought the timber was good. Our inspectors thought the timber was good, but we thought it'd probably be good to have somebody come in and have an independent third party come in and inspect the timbers and make sure that they are in good shape. And we wanted to keep this signature bridge in service for as long as we could. And so, so that was kind of the background to the project and what we were trying to accomplish. So we knew we didn't have the expertise in-house, and So we worked on coming up with a contract, and we solicited to try to get some of these tasks done, and we figured we'd do it in 2 different phases. You know, we'd do the inspection and do some non-destructive testing to make sure that the bridge is in good shape, and if there were deficiencies, what we might need to do to address those. We wanted the consultant to make recommendations for what work they thought we needed to do, and then to do a load rating to make sure that the load capacity was adequate for what we thought we had. And then depending on what phase 1 of the contract brought about, we'd proceed with phase 2, and phase 2 would be the design, bridge plans preparation, shop plans, and everything else that might arise during construction. So in 2017, we advertised nationally to try to find some consulting firms that would want to take this on, and there were a lot that wanted to participate in this project, and I think a lot of them wanted to have this picture up on their wall to say we worked on a bridge like this. And so we had a lot of good firms to pick from. We ended up entering into contract with Stantec in 2018 of January that year, and then they brought on Wood Research Development to provide some of the timber expertise that we all needed. So we got the contract signed in January. February, we started inspection and non-destructive testing. And in November of that year, they were able to provide us a report of what their findings were, along with the load ratings. The non-destructive testing that we did was what was called a stress wave timing testing, where basically you're measuring how long the sound waves take to travel through the timber. Usually the higher the quality of the timber, the faster the sound waves travel through. If you have some defects or deterioration, the sound waves take longer, they're slower. And then what we did was then we also took some cores of the timber to make sure we were correlating what we were getting with the non-destructive testing. And it's just kind of an example of what they were doing. Basically, you're hitting one side of the timber with a hammer and measuring how long it took that sound wave to travel through to a receiver on the other side. And so they did that thousands of times, and then they mapped everything out, what they found. Basically, we came up with just a little, green is good, yellow's maybe questionable, red, we're starting to get some deterioration that we needed to address. And the other thing that we did with this testing was we wanted to make sure we kind of established a baseline now of where we're at, so we wanted to come back in 15, 20 years, we could repeat these tests and see if we've slowed the deterioration down that was there, or are we getting any new deterioration. And so as part of the reports, they provided all of the timbers and color-coded, and so it made it really easy to try to identify some of the problem areas that we were going to have to address with this project. The consultant, as part of their recommendations, came up to replace the deck, which we pretty much knew we were going to have to do. They recommended to try to eliminate moisture to get into some of the timber where moisture was getting to those timbers, it's starting to cause some deterioration. They recommended trying to eliminate joints if at all possible. As we all know, joints leak, it gets to your substructure, your superstructure members, and so we want to try to control the moisture as much as we could on the timber, because keep the moisture away, you're not going to get deterioration. There are a few minor repairs to some of the concrete substructure, and some of the galvanizing was starting to wear off in places. And the initial load ratings were all good. We could carry all the legal loads that we needed for these bridges. But we do keep all overloads off. We don't permit any trucks over these bridges just to preserve them. So once we got the recommendations, we had a chance to digest them. We decided to proceed with phase 2 with Stantec, to have them provide the plans and proceed from there. So we were going to replace the decks in-kind, replace them with concrete decks. We were going to add stainless steel, re-steel, thinking that would help. And during the design process, we started talking about, should we try timber decks? Because one of the constraints we had with this whole project was construction had to happen between Labor Day and Memorial Day. They didn't want any construction going on in the summer because the traffic is so high out here with tourism that it was going to have to be winter construction. And so in visiting with Stantec and their research, or their wood research development, their timber experts, we started talking about, should we try timber decks? Because those could be built in the wintertime. And so we tasked the consultant to provide us some pros, cons of both ways. And so we did that. We said, well, let's look at the load carrying capacities, what changes will be there. Are there any details we have to think about differently if we use timber? The speedy construction would definitely help the contractor to get that built off-season. Are we going to still have a durable, have a good service life with timber? And what about the initial cost and maintenance costs for going with timber instead of concrete? So for the concrete, we talked about if we went stainless steel, that would help us a lot. We'd come up with some type of new expansion joints that would hopefully not leak like a lot of the older joints would. And the load ratings would be similar to what the load ratings were with the current concrete deck. And for the timber decks, we could eliminate basically all the joints because there wouldn't be any need for joints with timber deck. And our initial thought was, well, the timber's lighter, the load rating shouldn't be a problem. So we decided to go with that recommendation. And so we went with the timber decks with the membrane and asphalt overlay. And so we figured we could keep all of the water off the glue-lam timber structures. But one of the things we came across as we actually got into the design was that lower bridge was a composite. Well, we can't go composite with timber, and there was enough advantage from the composite concrete deck that a timber non-composite deck actually gave us a lower load rating, which initially we just thought wasn't going to be a problem, but when we actually ran the numbers, it was. And so one of the things we had to do is then, as part of this project, was we had to strengthen that lower bridge with some fiber to get the load rating capacity we needed. So the bid letting was May of 21, with the intent that construction would start that fall after Labor Day and have all the construction completed before Memorial Day of 22. Of course, out here in South Dakota in the Black Hills, winter can be very unpredictable, can be very changing. Like Steve mentioned earlier, last week here in Deadwood, they got 6-10 inches of snow. Today it's like, 75 degrees outside. So from week to week, day to day, you can have a lot of variable weather. And so the contractor, of course, is going to have a lot of risk not knowing what weather was going to be like over an entire winter. Core Construction was the low bidder on the project. He's one of our local bridge rehab contractors. He's actually a pretty small firm, but it worked out pretty well. One issue we had was that the bids did come in about 39% over the engineer's estimate. And if you remember, we were just coming off COVID, and timber prices were like through the roof when we let this project. But we decided that we couldn't really wait. If we waited, we'd have to wait a whole nother year. Otherwise, we'd miss our construction window. So we went ahead and absorbed that high bid cost with the high timber just because we need to keep this project moving. Now, the construction folks say this is the fun part, but to me, the fun part was getting up to this point, getting it built. That can be a pain sometimes. So basically, the sequence of the whole project was going to be we'd do our traffic control, we'd get the concrete decks removed, we'd do some timber diffusing, get the timber deck, timber rail on, do the tension retrofit, strengthening that lower bridge deck, do the substructure repairs, and then hopefully there will be a window to get the asphalt surfacing down in the spring before Memorial Day. Traffic control in an intersection like this was a little challenging, but I think they came up with a pretty creative solution. We basically created a large traffic isosceles triangle, basically. So we were able to keep traffic going through this interchange fairly safely during the project. So the deck removal, they saw cut the timber deck or the concrete deck into sections and lifted it off, and that worked pretty well. They marked everything out. They marked all the timbers below the concrete so they wouldn't cut into those timber members. And we were able to proceed. And here's just a picture. And of course, with the arch bridge, they started in the middle and they worked their way out from both directions, trying to keep the loads balanced as near as they could with that arch. One of the things that, as I mentioned earlier, on that lower bridge, the one that's not the arch, was that it was a composite structure. But what we didn't realize is what they had come up with to make that timber and concrete deck composite, and there was these very large metal devices. That's kind of what they looked like. They drilled into the top of the stringers, put those in, and those were basically the shear studs for the timber. We didn't realize how big those were going to be or what they even were. The upper deck just had more like a piece of rebar coming up out of the deck to act as composite, but here on this lower deck, these things were huge. So the contractor, we came up with a way to get those removed, which weren't easy. And so then we also fabricated timber plugs, got those treated with penta, and got those all driven into that top of the stringers. So you never know what you're going to come across in construction. Kind of gives you an idea what the holes look like and with them all removed. So it took a lot of work to get those out. One of the things we did, areas where we were starting to get maybe some deterioration from moisture in the timber decks, was what's called diffusing the timber. You guys have all probably seen the termite guy that comes around and uses borates and drills them and puts them all around your house to keep the termites away. Same type of principle here, where we're going to end up drilling holes into the timber, putting borate salt into those, and then putting a timber plug on the outside of the holes to help neutralize if moisture content does get to a high enough point to cause deterioration, that the borate salts will react with the critters. And so basically it was drill a hole, an example of what the borate salt rods look like, put them in the hole, hammer in the plug for where the hole was, and then repeat it about 2,000 times. So obviously something that the contractor could work on independently of the bridge decks, independent of weather. Definitely good winter weather work for the contractor. So now it's probably January, February timeframe. Got the deck removed, we've diffused the timbers. It's time to get the timber decks and to get the timber rail on, and the deadline's coming quickly. Here's kind of an example of kind of the timber deck. It came in pre-assembled panels. Of course, we had a super on the arch bridge and the lower bridge, and so we had to do a lot of surveying prior to placing the timber decks. Then we had to fabricate some HDPE shims for the timber deck panels to sit on to have good contact. And example of the timber rail. And of course, if you remember, we're 22 now. We're still coming off COVID, trucking issues. Everybody was having trouble getting products shipped across the country. A lot of our contractors were having a lot of problems getting materials, and our contractor had the same problem. The timbers were ready to go from Oregon, and he couldn't hire anybody to bring the timbers here. Nobody wanted to have a dead load back to Oregon, and so it took him a long time, but he was able to finally get somebody to haul all the timbers here. Happened to be in the Black Hills when they were testing out placing the first timber on the deck. As you can see, a small piece of machinery can lift that timber piece up, a couple straps. It's easy to move around, and the contractor actually did a real good job of being able to get these timber pieces down. Next up was reinforcing that bottom bridge, get the strength higher than what we, or get the strength up to what we needed. So we used basically a Kevlar, a glass aramid, plastic to, we attached it to a timber backing rod, and then we glued and then screwed that to the bottom of the deck, or the stringers. And then we had a few small repairs to make. Nothing out of the ordinary for a bridge that was, 55 years old. Then we had asphalt to place over the timber decks. At the joint at the bridge between the abutment and the timber deck, we just used a compression seal, and then we sealed over that and then paved over that. I know my presentation said I'd be doing a little bit of digital twin work. We haven't done very much with digital twins yet. We've just last 2 or 3 weeks ago, we actually used our drones to actually collect some data on these bridges as just kind of a, what can we get out of this? And one of our region bridge engineers, who's actually speaking next, Josh Olson, he flew the bridges and kind of got some models created. I haven't used Bentley products forever, but I was able to at least get a couple screenshots, at least show you that we're kind of getting down that path of trying to collect digital twins and trying to learn what we can and can't do with those. And these are just a couple shots that I took from the models that Josh created. And that's kind of what the final product looks like. It looks really good. In fact, I think the timber decks actually look even more authentic than the old concrete decks do. So I think we didn't have any adverse reactions with changing the deck type. And the contractor got everything done in time for Memorial Day, so everybody could come on vacation out here in the Black Hills. And so I think it was a very successful project. I think it was one of those once in a lifetime projects to get to work on, and it was quite the honor to be part of this project. So, so with that, I think we've got time for a few questions. If you do have a question, raise your hand, and Todd or somebody else will run a mic to you. Since this is being recorded, we'll make sure we hear. Back over there. And I'm not a timber expert, so I may not be able to answer it, but.
Oh, hi. Yeah, so I'm wondering about why the timber deck wouldn't need expansion joints when the concrete deck did.
The amount of movement was so small that it could absorb whatever, because these aren't very long structures, so. But yeah, I mean, good question, but Dan Tingley from Word Research Development said we'd be fine with the lengths that we were at with the timber. Otherwise, right here.
Are we using?
Just hold up until the mic, because this is being recorded so everybody can hear it later.
During the winter times, for maintenance reasons, are we using salt on this bridge?
Good question. I don't know if they're applying salt directly to the bridge, but I'm sure there's salt being tracked onto the bridge.
Yeah, thanks for the presentation. What are you doing with the drainage on that bridge? Where's the water go, and how do you collect it so that it doesn't, go?
Yep. What we did was the original rail, when we designed it, was going to spill onto the deck below. So we added curb blocks where it was going to spill over onto the bridge below. But otherwise, it's going to go on the face of the timber deck, but then it doesn't get to the actual arch or because they're both on a super, so it's going to run off. So.
Quick question. Did you guys look at fiberglass rebars at all or not?
No, we didn't look at fiberglass rebar. Okay.
I was curious about the pins that hold the arches together. Were they studied and did they need to be replaced?
We've done some non-destructive testing on the pins, and they've been fine so far, as much as you trust that.
When you were looking at the deck types, did you guys consider precast concrete panels?
Probably not really, just because between each panel you're going to have a joint, and anytime you have a joint, there's going to be a potential for water to get to the timbers below. We could have, post-tensioned, but we didn't really look at it in much detail. So, and I guess if you guys have any more questions, you can always catch me at the social tonight or buy me a beer downtown, and I'll answer a lot of questions. Okay.